Good morning. We are the Sepsis Surveillance Squad, and we'd like you to meet Sam. He's a firefighter, and during his last call, he was severely burned and rushed to the ER. Now he's in the burn ICU. Sam's immune system, trying to defend his wounds from infection, is going into overdrive. This is known as sepsis. Sam is unfortunately not alone. 40,000 patients are hospitalized annually. Of these patients, 50% will die from sepsis. Every hour Sam goes without antibiotics, his chance of survival decreases by 8%. The current standard of care is measuring a patient's baseline SOFA score. A SOFA score represents organ dysfunction, which is a direct consequence of sepsis. When the score increases by at least 2, a healthcare provider typically will order a blood culture to measure the bacteria, and this can take up to 3 days to produce results. For many patients, this is too late. This weekend, we set out to develop a solution. Presenting SepSense. Our solution has 3 main components. 1. Biomarkers that change as patients progress towards sepsis. 2. A device to measure the concentration of each biomarker. 3. A display that alerts healthcare professionals when a patient is at high risk for sepsis. Now, you might be asking, how do we know which biomarkers to measure? We propose these 4 biomarkers for their availability in the tissue we're looking at and their high accuracy in predicting sepsis. Our device is a patch with microneedles inspired by the design of a continuous glucose monitor. This is our blown-up prototype of a single needle, which measures the 4 identified biomarkers. When this needle goes into the skin, the biomarkers will bind to the antibodies in the wells at the bottom. The physical presence of these antibodies causes impedance to increase, which is then picked up by the electrical controller. This needle is one of 3 that sends data to the electronics board. The patch holds the board and the needles in a neat bundle, and this is all secured to the patient with an adhesive layer. Just like the alerts that would go off if Sam's vital signs deteriorate, our device will alert healthcare workers when Sam is at risk for sepsis. Management of sepsis relies on the early detection of infection. Our device produces a result within minutes, while the current gold standard takes up to 3 days. We reduce antibiotic overuse and reduce hospital length of stay, which increases hospital bandwidth. It costs the hospital a lot of money to take care of Sam in the ICU. Using our device, hospitals would be saving more than $5,000 for every day we speed up Sam's recovery. Moving forward, we will conduct clinical trials with our device and get FDA approval. We will train a machine learning model on patient data and use it to improve sepsis prediction accuracy. More research and development on biomarkers that accurately predict sepsis will allow us to reduce the cost of this device. And finally, we aim to expand early sepsis detection beyond just burn patients. Integrating our device with hospital systems ultimately saves the lives of burn patients like Sam who slip through the cracks of sepsis diagnosis. Thank you.